Hello everyone, I am Atılım. In this video, we will solve one problem in chapter 4. An object is thrown with an initial speed of 20 meters per second at an angle of 30 degrees below the horizontal. If the horizontal range of the object is 30 meters, calculate A. its initial height and B. the magnitude and direction of its velocity just before hitting the ground. In part A, first of all, let us find the initial speeds in the x and y axis. The x component of the initial velocity is vx0 equals v0 times cosine theta 0. With the corresponding numerical values, we find it as 17.321 meters per second. And the magnitude of the y component of the initial velocity is calculated to be vy0 equals v0 times sine theta 0. With the numerical values, it is calculated to be 10 meters per second. Therefore, according to the configuration, the initial velocity can be written as vx0 I hat plus vy0 minus j hat. Or by the numerical values, it can be written as Now we shall find the flight time using the range of the motion, that is the x component of the final position. Then we use this formula. Here x0 is 0, and since the speed in the x component is constant, then x component of the acceleration is 0. As a result, we obtain xf equals vx0 times t. From this equation, we obtain an expression for t as xf over vx0. If we insert the corresponding numerical values into this equation, we get the flight time as 1.7320 seconds. Next, to find the initial height, we use the y component of the position. Then it is convenient to use this formula. Here y0 equals 0. And the y component of the acceleration, that is ay, is equal to the gravitational acceleration, which is in the negative y direction. So we write minus j. And noting that yf equals minus h, we have. Therefore, we obtain an expression for h as, if we substitute the corresponding numerical values into this equation, then we obtain the initial height as approximately 32 meters. In part B, we find the x and y components of the final velocity. X component of the final velocity is found by this formula. Since the acceleration in the x direction is 0, then we have vxf equals vx0. That is 17.321 meters per second. Next, the y component of the final velocity is calculated by this formula. Here, ay is equal to minus g. Then we have vy0 minus g times t. With the corresponding numerical figures, we obtain negative 26.974 meters per second. As a result, in unit vector notation, the final velocity vector becomes, now we can find its magnitude by this formula. So we get approximately 32.1 meters per second. And angle theta is calculated by this formula. Therefore, we obtain approximately negative 57.3 degrees. Okay, that's all about this problem. Thank you for your attention. See you in the next video.